Ever struggled to make sense of logs scattered across different severity levels in a distributed system? FastMCP 2 gives you fine-grained control to handle all 8 log levels, from debug messages to emergency alerts, with custom formatting and routing. We'll implement a log handler that processes structured messages containing both the core log text and additional context data. You'll see how to apply different formatting for errors and warnings while cleanly handling the 6 other severity levels, all while preserving the optional logger categorization and extra structured data that makes these logs powerful for debugging complex systems.
A sync def detailed log handler message. Log message. MSG equals message, data get MSG. Extra equals message, data get extra. If message level equals error. Print F error, MSG details, extra. Elif message level equals warning. Print F warning, MSG details, extra. Elsie. Print F message level upper, MSG.
This demonstrates the structured logging handler pattern for distributed systems, specifically implementing FastMCP's standardized log message processing. The concept centers around receiving machine-readable logs with fixed fields, level, MSG, extra, and applying consistent formatting rules based on severity, where the handler acts as the single processing point for all server-emitted logs. The distinctive aspect is its support for 8 standardized severity levels, debug through emergency, while maintaining extensible contextual data in the extra field. The pattern works by establishing a clear contract where servers emit logs with guaranteed MSG and extra fields, though values may be none, while handlers determine presentation and routing. The conditional logic explicitly highlights critical issues, error level, and potential problems, warning level, while the fallback case cleanly handles the remaining 6 levels, debug, info, notice, critical, alert, emergency, with uniform formatting. This design enables both human-readable output and machine processing capabilities, with the optional logger field available for categorization when needed. This approach matters because it solves the challenge of consistent log analysis across distributed components and proxies. By standardizing both the log structure and severity levels, you enable reliable log aggregation, filtering, and alerting, critical for debugging complex systems. The trade-off is minimal. Handlers must implement the basic message structure, but gain the ability to process logs from any FastMCP server while preserving all contextual data for analysis. The pattern particularly excels in microservice architectures, where logs from multiple services must be correlated and analyzed together. Let's break it down line by line.
A sync def detailed log handler message. Log message.
This async handler processes FastMCP's structured log messages with 8 severity levels: debug, info, notice, warning, error, critical, alert, and emergency. The conditional logic explicitly highlights errors and warnings, while the else clause handles the remaining 6 levels uniformly, maintaining clean output for all operational scenarios. The log message structure guarantees MSG and extra fields, though values may be none, with the extra field specifically designed for structured, queryable log data that enables analysis across distributed systems. This pattern decouples log emission from processing while preserving all contextual information for operational visibility.
MSG equals message, data get MSG.
Extracts the message text from FastMCP's structured log data, which always contains MSG and extra keys per the framework's contract. Uses get as a defensive pattern that gracefully handles none values while maintaining compatibility with FastMCP's 8 log levels: debug, info, notice, warning, error, critical, alert, and emergency. This enables consistent processing, whether the log carries simple text or structured data in the extra field for queryable logging systems.
Extra equals message, data get extra.
Extracts the structured extra field from log data using get, which safely handles none values while maintaining FastMCP's guarantee that the data dictionary always contains this key. This field carries machine-readable context for queryable logs, enabling structured analysis across the 8 supported severity levels, debug through emergency. The pattern ensures critical operational data remains accessible even when optional metadata isn't provided.
If message level equals error.
This conditional implements severity-based routing for FastMCP's 8 log levels: debug, info, notice, warning, error, critical, alert, and emergency. The error branch handles just error-level messages, while the warning branch handles warnings specifically, and the else clause processes the remaining 6 levels with a standardized format. FastMCP guarantees the data field contains MSG and extra keys, though values may be none, with extra designed for structured data to enable queryable logs in distributed systems.
Printf error, MSG details, extra.
This formats error logs with explicit severity labels and structured details. The pipe-separated output ensures critical issues stand out while maintaining machine-parsable structure for the extra field's key value data. The pattern handles all 8 MCP levels, debug through emergency, with special formatting reserved for error and warning cases while defaulting to a clean format for the remaining 6 levels.
Elif message level equals warning.
This handles warning level messages in FastMCP's 8-level severity system: debug, info, notice, warning, error, critical, alert, emergency. The conditional ensures warnings get distinct formatting from the 6 other non-error levels processed in the else clause, maintaining clear operational urgency hierarchy. The extra field carries structured data for queryable logs, while the logger field enables categorization in distributed systems.
Printf warning, MSG details, extra.
This prints warning messages using FastMCP's structured logging format, combining the main message with optional structured details from the extra field. The consistent warning, prefix, and pipe-separated details create parsable logs that work with log aggregation systems, while handling one of FastMCP's 8 supported levels: debug, info, notice, warning, error, critical, alert, and emergency. The pattern mirrors the error handler, but maintains proper severity distinction for operational monitoring.
Else.
The else clause handles all non-error, non-warning log levels, covering debug, info, notice, critical, alert, and emergency, using a standardized format. This ensures consistent output for the 6 remaining FastMCP severity levels while keeping error and warning messages visually distinct. FastMCP's log message guarantees MSG and extra keys in the data field, though values may be none, so get is defensive but not strictly required for existence. The extra field is designed for structured data, enabling queryable logs in distributed systems.
Printf message level upper, MSG.
This handles all non-error, non-warning log levels with a standardized format. FastMCP supports 8 severity levels: debug, info, notice, warning, error, critical, alert, emergency. And this else clause processes the 6 remaining levels uniformly. The upper ensures consistent capitalization while maintaining clean output for informational logs, creating clear visual distinction from high-severity messages that include detailed extras. Structured logging pattern. FastMCP's log handler processes standardized log message objects containing level, data, and optional logger fields, transforming raw server events into structured output across 8 severity levels: debug, info, notice, warning, error, critical, alert, and emergency. The conditional logic explicitly formats only error and warning messages with extended details, while the else clause silently handles the remaining 6 levels with uniform presentation. FastMCP guarantees the data field will contain MSG and extra keys, though values may be none, making the defensive get calls future-proof rather than strictly necessary.
The log message that carries all details becomes most useful when it carries none.